Finally, I want to relate this back to the projects that we're asking you to do in this course. Here is a simplified diagram of our Y86 processor. We're not asking you to write a hardware simulator in this course, so we're not going to have you emulate every single little bit of the X86 CPU. But what we're asking you to do is write some C code that emulates the behavior, or that interprets a Y86 program in such a way that the final effects are the same as if you had sort of run it on simulated hardware. So what that means is that there's going to be some form of each of these 6 stages somewhere in either your project 3 or your project 4. So the fetch phase is part of project 3. So this is the one that reads in instructions from memory and kind of takes the pieces and arranges them so that the later stages can use all those pieces. And you did this in project 3, actually, when you pulled in data and you put it into this Y86 instruction struct. So that's really the that's really sort of all these little pieces all kind of put together into a struct. And that's going to be an input to the later stages. And so I've denoted that here in the diagram with a little red dotted circle around it. So in project 4, we're going to implement the rest of these phases, and we're going to split it into 2 routines just to make it a little bit clearer how it should work. So the first routine is going to be the decode and the execute stages. So that's going to do the reading from registers. It's going to do whatever sort of arithmetic or logic operation we need to do. So the communication that happens between these stages is that in the decode and execute, we'll use the pieces of the instruction that we fetched in the fetch instruction, or in the fetch stage. And then we are going to set a few things that are going to be used in later stages. So some of the things that are used here, like val B, are entirely self-contained within this stage, and we don't need to expose those to later stages. And so we're going to let you implement that however you'd like. But there are a few things that we're going to use to communicate between decode, execute, and the last 3 stages, which we're going to put together into one routine called memory write back PC. And so the important piece of information that those phases need from these 2 phases are the val E coming out of the ALU, the condition flag about whether we're going to take a conditional jump or a move or not, and val A, which is a value coming from a register. So those are going to be things that are set or returned from decode execute and are going to be inputs to the memory write back and PC update. And that'll be the last 3 stages, and then the process will start all over again with the new program counter that was presumably set during that last stage. So hopefully this clarifies a little bit about what's going on in Project 4 and how it relates to all the things that we've been talking about in this architecture module so far.